Okay, today we're going to be doing section 5.3, day 1, and then on Monday we will just go over this again and kind of finish up 5.3. So 5.3 is more into probabilities, and this is the section that's a little bit, you have to pay a little bit more attention to this section. Um, it might not be quite as intuitive as 5.2, and there's more formulas that you can follow now. Um, so really take good notes on this and follow along as best you can. Okay, now we've done this, we've seen this table before, and now we're going to just kind of add on to it on different probabilities that we can find with it. So up here I have defined that event A is being female and event B is having pierced ears. So let's say I wanted to find the probability of A, the probability of being female. Okay, well, look at the females. The probability of being female, there's 88 females out of a total of 178. Okay, let's say we want to find the probability of event B, which is having pierced ears. So the probability of having pierced ears. There are 103 people with pierced ears out of the 178. Okay, now the next one is probability of A and then this symbol. See if you can remember what that means. B. This symbol means and. A and B. So the probability of being female and having pierced ears. So females with pierced ears are 84 out of the total 178. Okay, now the next one is the probability of A union B. That also means or, A or B. So the probability of being female or having pierced ears. Now there's an overlap. There are some females with pierced ears. Anytime you have an overlap, you need to find the probability of A plus the probability of B and then subtract off the overlap, which is the probability of A and B. So we have all that stuff. We already found that the probability of A is 88 over 178. We found the probability of B, having pierced ears, is 103 out of 178. And then we have to subtract off the overlap, those females who have pierced ears, 84 out of 178. And then when we figure that out, we get 107 out of 178. All right, now these next two problems are newer. You see the word given? Okay, that is going to change things. I'm going to erase all this stuff we did up here. Okay, find the probability that a randomly selected person has pierced ears given that the person is female. So we need to only look at the females because it's given that the person is female. Okay, so let's only focus on being female. Out of the females only, What's the probability that a person has pierced ears? Well, 84 have pierced ears. 84 females have pierced ears. So 84 out of the 88 females. It's different now because we're only focusing on females. Okay. Now for the next one, find the probability that a randomly selected person is male given that they have pierced ears. So we're only going to look at people with pierced ears. Okay. It's given that they have pierced ears. So we're only looking at the people who have pierced ears. Find the probability that a randomly selected person is male. Okay, 19 males have pierced ears. So out of the people who have pierced ears, 19 of them are male. Okay. All right, now, a conditional probability is the whole thing we just got doing about given. So the conditional probability is a probability that an event happens under the condition that another event has taken place. This is the notation for conditional probability. When you see that line there, that means conditional probability. And this is read the probability of A given B. So the probability that A happens given that B has already happened. Okay, so here's another kind of example here. If we roll a dice, what's the probability that we roll a 3? Okay, well, when you roll a dice, you could have 1, 2, 3, 4, 5, or 6. So the probability of rolling a 3, that happens 1 out of the 6 possibilities. All right, that's easy. Now we're going to do, what's the probability that we roll a 3 given that we rolled an odd number? That's how I would write it out. Probability that we roll a 3 given, so that's that line, that we rolled an odd number. So now we're only going to focus on the rolls that would be odd numbers. So that would be 1, 3, or 5. Only focus on these. What's the probability that we roll a 3? That's a 1 in 3 chance now. So it's a little bit different when you have this condition here. Probability of rolling a 3 on condition that we already rolled an odd. Okay, so these are our odd possibilities. Rolling a 3 is 1 out of the 3 possibilities. Okay, now there's something called the general multiplication rule. This is it. So this is the probability of A and B equals the probability of A times the probability of B given A. But this does not show up on your formula sheet. What does show up on your formula sheet is the one in the pink here. So this is the one you should get familiar with. It's the same as this purple one, just rearranged. So the probability of B given A is the probability that A and B, the probability of A and B happening, divided by the probability of A alone. Okay. Now, the probability of A given B and the probability of B given A are not the same thing. Here's the two formulas. If you look at the tops, they both have A and B, so that's highlighted in yellow here. The tops are the same. But if you look at the bottom's different. So if we're doing probability of A given B, B is on the bottom. probability of B given A is on the bottom. So basically, whatever you're given, that probability goes on the bottom. Whatever you're given, that probability goes on the bottom. Now on your formula sheet, I believe this is the only one that they list. So you have to know, okay, if I want to do the probability of A given B, the top is the same, probability of A and B, that's the same, but now on the bottom is what I'm given, the probability of B. So you're given on your formula sheet, the pink box, you have to know this. Okay, so now we're going to do an example. In an apartment complex, 40% of the residents read USA Today, 25% read the New York Times, and 5% read both. Remember, we did a problem like this already, but now this is going to be a little bit different. Okay, what's the probability that the resident reads USA Today or New York Times? Okay, probability of USA Today or New York Times. Well, there's an overlap, right? Some people read both. So when there's an overlap, you have to subtract off the overlap. So this would be the probability of reading USA Today plus the probability of reading New York Times minus the overlap, which would be USA Today and the New York Times. Okay, so remember this is an or and this is an and. Okay, well we have everything we need because they tell us that the probability of reading USA Today is 40%, so 0.40, and they tell us that the probability of reading New York Times is 25%, so 0.25, and then they also gave us the information that reading both of them, USA Today and New York Times, is 5%, so we're going to subtract off 0.05 and type all that in your calculator and you get 0.6. Okay, now you can leave your answer like that, or you can move the decimal place over twice and you could say 60%. Okay, now the next question is a conditional probability problem. It says, what's the probability that the residents read the New York Times given they read USA Today? So it's conditional probability. The probability that they read New York Times given that they read USA Today. Okay, so we're going to follow the formula from the previous page. The top is and, New York Times and USA Today. It's always and on the top when you're doing conditional. On the bottom, it's the probability of whatever we're given. We're given that they read USA Today, so that goes on the bottom. Okay, so we're just going to fill in that stuff. We already know all of this already from the previous problem. So the probability of New York Times and USA Today, that was 0.05. And the probability of USA Today was 0.40. And we just divide those and we get 0.125. You can leave it like that, or you can say 12.5%. Either works. Okay, now I'm going to record a second part to this video, so now go to part 2, and then when you're done with part 2 you can work on the homework and I will help you with your questions on Monday. So now go to part 2.